Hello, this is Mr. Ree. It's good to see you on YouTube video. I'm gonna go over some of the problems that look relatively similar to the test problems that you took, the chapter 1 test. And if you check the Blackboard and if your test score is below 80, you might have to do some form of test corrections. So I already gave you the handwritten solution manual, but I wanted to go over in detail some of the problems that might help complete the test correction. So the first one is 1.6.1, first page in the review material, by the way, and I'm going to go over C. Well, anything, no matter how big, to the power of 0 is not 0, by the way. It's 1, right? And I'm gonna go move on to F. Now, I have negative exponent. You might want to take care of that first, right? So, what's the cost of changing negative 4, negative exponent, into positive exponent? So in this case, positive 4 instead of negative 4. You have to reciprocate the base. And when you reciprocate the base, that means you change the numerator and the denominator. But reciprocating does not really change the sign, right? So the negative sign stays for now, and it's going to be 3 over 1. And that's the same thing as negative 3 over 1, just negative 3, right? To the power of 4. And now you have even power. So this negative sign will disappear, because when you multiply a negative number even number of times, the negative sign will be cancelled away, right? So this is just positive 3 to the 4th power. And if you multiply 3 4 times, it's not that big. It's big, but it's not that big. It's 81. So you might want to write this type of answer when you do the test correction for chapter 1 test, right? Okay. Now I'm going to move on to 1.6.2, and I'm going to do D and E. Let's do D first. Okay, I have two parts in the equation. This is simple enough. I don't have much to do with this. But maybe I can rewrite 1/4 in different way, because 4 is actually family of 2, right? I can rewrite 4 as 2 squared, right? So it's getting closer to the right side of the equation. But I still have a fraction. How do we take care of that? By changing the power 2 into negative 2, the denominator will move up to the numerator, right? So it's going to be same thing as 2 to the x. Now that you have same base 2, that means these have to be same as well. So x equals negative 2. That easy, right? Now, obviously, you want to work on the right side of the equation, because this is already simple enough, right? And 3 is already 3, but this is family of 3 and that's family of 3. So let me try to rewrite this whole thing using all the bases of 3, right? So 9 is 3 squared, but don't forget there was already square there, so you can't just ignore that, times 3 to the 1 power. By the way, there's invisible power 1, right? All over, well, 27 is 3 cubed, and there was square there, so I have to square the whole thing. That's gonna equal 3 to the x power. Now that I have all base of 3, let me simplify that a little more. You multiply these two powers, it's going to be 3 to the 4th power times 3 to the 1 power over, do I add this or do I multiply this? Yeah, you have to multiply them. When do you add? If you have 3 cubed times another 3 square, if you have two separate bases being multiplied, then you add them. But here you only have powers, right? In this case, you multiply them, not add, okay? So it'll be 3 to the 6th power, because 3 times 2 is 6, right? So this will be same thing as, well, now you add these, right? Because you have separate bases being multiplied. So it'll be 3 to the 4 plus 1, which is 5, all over 3, 6. Now, where do I have bigger power? I have bigger power in the denominator. And 5 3's being multiplied will reduce 5 of these 6 3's being multiplied, leaving only 1 3 on the bottom, and everything was reduced to 1. So 1/3 is going to be the answer. No, not yet, not so fast. Because what did they ask you? 3 to the x power equals 1/3. So we're almost there, right? My job was finding not 1/3, but just x, right? So what do? Well, 3x is 3x, but I can rewrite this as, without fraction, it will be 3 to the negative 1 power. Now we see that x equals negative 1. So x equals negative 1. That's the final answer, not 1/3, okay? You needed to find 1/3, but since they asked you to find x, it has to be negative 1. And I'm gonna move on to 1.6.6, and I'm gonna go over C, Star Spangling C, right? So let me enlarge this. All right. Well, 2 is simple enough, but I think I can break down 40, right? How does that break down? Well, if you doubt, just do prime factorization. So when you do prime factorization, you have to start with the smallest prime number that goes into 40. Since it's even number, ending with even number, you have to start with 2. And you have to keep on using the smallest prime number until you can't, okay? So 2 still goes in there 10 times. 2 still goes in there 5 times. And if I end up with prime number at the bottom of the apartment, at the bottom of the tower, then you're done. So you can rewrite 40 as 2 multiplied 3 times. So 2 cubed multiplied by just 1/5. That's the prime factorization of 40. So if I write that here, it's going to be negative. By the way, you can't just ignore this negative sign. I have to copy it down. And instead of 40, I'm going to write down its prime factorization, which is 2 cubed times 5. And don't forget the power that was there, right? That will do something, right? Can't just ignore that. Over, well, I'll just copy this one down, 2 to the 30, nothing you can do. But I can do something about this, right? 25, we know that it is 5 squared, right? And then don't forget the cube that was already there. So it's going to be like this, right? Now, I think I can break down the parentheses. By the way, is this negative sign going to stay or disappear? When you have all the power, this negative sign will stay. So it will still be there. And you multiply 3 and 7, so it will be 2 to the 21 power. And then 5 to the 7 power, right? My 7 kind of looks weird, people say. But that's my 7. I can't change my habit. I've been writing 7 like that for many years, right? And then all over 2 to the 30th power. And do you add them or multiply them? Again, multiply them. It'll be 5 to the 6th power. Okay. There you see your favorite numbers, right? Anyway, now this negative sign will stay, but I think I can reduce the same basis. I have more 2's being multiplied in the denominator than numerator. So 21 2's will reduce 21 of the 32's in the denominator, leaving how many? 2 to the 9 power, because 30 minus 21 is 9. Okay, so the bigger power side remains, okay? Now, 7 is greater than 6, and 6 5s being multiplied will reduce 6 of the 7 5s being multiplied, leaving only 5 on the top, 5 to the 1 power. You could, let's not leave this like that, because I know this is big number, but we can still figure it out. If you multiply it to 9 times, that's going to be negative 5 over 512, and that's the final answer. Okay, not that bad, right? You have to practice. You have to practice all these problems on your own, okay? And then do the test corrections when I give you test correction material, right? And the next problem will be 1.7.1. I'm gonna go over D. All right, it's a big number, 7,056, right? I think I gave you even bigger number in the test. All you have to do is prime factorization. So it'll be 7,056, and it ends with even number, so 2 should work, and it's gonna be 3528. If you doubt, if you wonder how I got that number, do the long division or the shortcut method that I showed you last time, right? And then if you do 2, and again 2 still works, right? It's gonna be 1764, and I can use 2 again. That's gonna be 882, and half of 8 is 441 if I use 2 again, right? Now I can't use 2 anymore because I'm ending with 1, so it's gonna be odd number. So what's the next smallest prime number? Maybe 3, right? 3, yeah, it does go in there 147 times. And can I keep using 3? Because you have to keep using the smallest prime number until you can't, right? Oh yeah, it goes again, it's 49. Can I keep using 3? No, 3 does not go into 49. So it's going to be 5. 5 is next smallest prime number. Well, 5 does not go into 49. 7. Oh yeah, 7 goes in there 7 times. Oh, I ended with prime number at the bottom. That means I'm done, right? So how many 2s? Let's count. 1, 2, 3, 4. So 4 2s being multiplied. 1, 2, 2 3s being multiplied. 7, 7, 2 7s being multiplied, right? So I'm gonna replace this prime factorization for this one, right? So I can rewrite this as parentheses. Instead of 7,056, I'm gonna write down 2 to the 4th power, 3 squared, and 7 squared. And don't forget this power, 1/2. Now, you have 2 different ways to do this. The first method is you can distribute it and multiply each pair, right? And that's going to give you 2 to the, what's 4 times 1/2? 2. What's 2 times 1/2? 1. What's 2 times 1/2 again? 1 again, right? So that's going to give you 4 times 3, which is 12. 12 times 7, that's 84, isn't it? What's the other way to do it? Since we know that 1/2 power is same thing as what? Square rooted, right? We can rewrite this as square root of 2 to the 4th, 3 square, and 7 square. And since this is square root, if you don't see any number, it's square root, right? Who can come out of the square root prison? Anything that is squared. The key for the square root prison is squared. And I think I can rewrite this as square root of something. This is square root of, let me not write 2 anymore. It's automatically square root, right? I can rewrite 2 to the 4th power as square root of 2 square, isn't it? Because 2 times 2 is 4, right? And then 3 square, and then 7 square. So who has the key? 2 squared, which is 4, has the key, so it can come out. 4 can come out. 3 has the key, right? 3 has the key, so 3 comes out. 7 has the key, so 7 comes out. Nothing else remains inside the square root. It's square root of 1 then, right? And we don't bother write square root of 1. It's that same thing as 1. That also multiplies to be 12 times 7, which is same answer. It's supposed to give you same answer, by the way. The answer is, either way, 84. Now, if I move on, I'm going to go over 1.7.3 D. Okay? Again, it's 1.7.3 D. Wow, this is amazing. I have fractional exponent and negative exponent at the same time. Remember, negative exponent has something to do with reciprocating the base, changing the numerator and denominator, right? And fractional exponent has something to do with root. The numerator of the fractional exponent, powers, and denominator, root. Remember, B, P, R, top powers and bottom roots when you have fractional exponent. Let's use that idea. So I'm going to take care of the negative exponent first. So I'm going to change that to positive 4 over 3 instead of negative 4 over 3. What's the cost of changing negative exponent to positive exponent? Reciprocate the base. So it'll be 1 over negative 8. Right? Now, would you root first or power first? It doesn't really matter. But when you power first, the number gets sometimes too big. And it's kind of hard to find how you can root it, right? So it's easier if you make the number smaller by rooting it and then power later, right? So let me do cube root first, right? So it's going to be cube root of 1 over negative 8, and then I'm going to power that by 4. Now, when you have cube root of the entire fraction, you know I can separately write cube root on the top and on the bottom, right? Because roots are flexible with multiplication and division, right? So I can rewrite this as, well, what is this? Cube root of 1. The same thing as 1, isn't it? Cube root of 1 is 1 because 3 identical numbers that multiplies to be 1 is just 1, isn't it? Now, what is cube root of negative 8? What are 3 identical numbers or 3 same numbers that multiply to be negative 8? It's negative 2, right? Negative 2 times negative 2 times negative 2 is negative 8. So negative 2 is in the denominator. And still not forgetting 4. Now, this power 4 powers top and bottom. And guess what? Since this negative sign is inside the parentheses, it'll be influenced by this even power. So the negative sign will be actually gone. And what is 1 to the 4th power? It's still 1, right? And what's the 4th power of 2? Since negative sign is gone, is 2 to the 4th power. That's 16. So it'll be 1 over 16. And that's the final answer for D. And moving down, 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 down. I'm going to go over 1.7.5. D, the star spangling one again. Now, I see 3 different bases. 2, 5, and 8. 3 different kinds of bases. But I think I can rewrite 8 as power of 2. There, it is relative of 2, right? So 8 is 2 cubed, and that's gonna be multiplied by this 2 that was already there. So it's 2 to the 6th power, and then you're gonna multiply 5 3rd power, and there is 3 5th power outside the parentheses. Now I have in the denominator, 2 to the 3 over 5 power multiplied by 5 to the negative 1/5 power. Now, the top one has parentheses, so let me break that down. I know this is 6, and if you multiply 6 by 3 over 5, that will be same thing as 2 to the 18 over 5. Wow, getting messy, right? And if I multiply 3 by 3/5, that's going to be 9 over 5. Teacher, I think it's getting more complicated. Oh, we'll have to see, right? And you have 2 3/5. I'm going to just copy that down. And 5 negative 1/5. Now, if you remember, when you have same bases being divided, what do you do with the powers? What do you do with the exponents? You subtract it, right? So this is same thing as single base 2, 18 over 5 minus 3 over 5, right? Good, they have common denominator. I can just combine the numerators then, right? And then when you have 5, if you make it single base, you again have to subtract the exponents. So it'll be 9 over 5 minus, be careful, negative 1 over 5 in the denominator. Now if you try to simplify this, so now that I have common denominator 5, I can subtract 18 minus 3, that's 2 to the 15 over 5 times, this base is 5, and you know subtracting a negative number is same thing as adding, right? So it'll be 9 over 5 plus 1 over 5, right? Okay, I see where it's going. So 2 to the, oh, I think I can reduce this. 5 goes in there 3 times. So that's same thing as 2 cubed. And if I add them, it'll be same thing as what? 10 over 5. And that also reduced to be 2. So it'll be 5 squared. And what is 2 cubed, by the way? 2 times 2 times 2? That's 8. What's 5 squared? That's 25. So you have quarter, 8 quarters, that's $2. So it's going to be 200 cents, right? So 200 is the final answer. And moving down, down, down again, 1.8.1. And I gave you a problem similar to this one, right? So let me work on that one. So you have decimal number inside the root. And if you remember, it's easier if you change that to fraction actually without decimal number. So how do you write 6.76 in that fraction? Since the decimal moved twice to the left, that means you divided 676 by 100, right? So you can rewrite this as this fraction. Now, if you remember, I have square root of the fraction. That means I could put square root on top and bottom separately. Okay? Now, I know it's harder to see, but if you do prime factorization, this is actually perfect square. This is perfect square of 26. So it'll be 26. If you doubt, you can run prime factorization, by the way. Okay? 676 is 2 square times 13 square, by the way. And that same thing as 2 times 13 square at the same time. And that's 26 square. Okay? So this is 26. And we know that root 100 is same thing as what? 10, right? So you can leave the answer like this, or you can change that to decimal number, which is 2.6. Since we started with decimal number, maybe it's good to end with decimal number. Or if you just write this fraction or a reduced fraction, which is the same thing as 2 goes in here 5 times and 13 times, maybe 13 over 5, that's also a good answer. Okay, so any one of these answer will be good, right? All right. one more problem from 1.8.1. Let me go over this one. Okay, now, all right, I could copy down the negative sign, and 27 I could rewrite that as 3 to the third power, because 3 times 3 times 3 is 27, and square root can be rewritten as what? It can be rewritten as 1/2 power. Remember, fractional exponent is the same thing as root. And then there's 3 outside, right? Then what do you do? Well, let me multiply these two first. And negative 3 over 2. And then I have cube here. And if you multiply these, it'll be negative 3 to the 9 over 2. Right? So is this simplest answer? Because the question was simplify each of the following, right? No. I think I can rewrite this, because if I rewrite this part as mixed number, that's going to be negative 3, 4.5. And if you remember what mixed number is actually 4 plus 1/2, right? It's not 4 times 1/2, but 4 plus 1/2. So I could rewrite this as negative 3, 4 plus 1/2. Now what? Remember this exponent rule? A to the n power times a to the n power is am plus n. I can use this rule the other way around. If you have sum of two numbers in the exponent, I can rewrite that as multiplication of two separate bases, right? So I could rewrite this as negative 3. By the way, this negative sign is not under the influence of the power because we don't have parentheses. Okay, so you have to copy down this negative sign just each time. And I can rewrite this as 3 to the 4th power multiplied by another base 3 to the 1/2 power. I know it's complicated, but it works, right? And now what? This will be same thing as negative, what is this? 81. What is that? Square root of 3. And that's the final answer. You really have to practice a couple of times, okay? Before you do the test correction. All right? So hopefully you understood it. And let me move down to 1.8.2. Let me do C. You have similar problem in the chapter 1 test. All right, let me enlarge this. I have 4th root. This is so small to look at, but it's 4, okay? It's 4th root. And I could separate the root top and bottom. 4th root of 32 and 4th root of 625, right? Oops, 625. It's easier to see than fraction, right? Now, what's the biggest 4th power that goes into 32? 32 itself is not 4th power of something, but 16 goes in there. 16 is 4th power of 2, isn't it? So 2 to the 4th power, which is 16, times 2 is 32. Now, is this itself a 4th power of something? Yes, it is. Luckily enough, it is 4th power of 5. So I could rewrite that as 5 to the 4th power. So guess who comes out of the 4th root prison? 2 has the key, so 2 comes out, but too bad for this 2 that stays inside 4th root. Okay? And how about the bottom? You have 5 that has the key for the 4th root, so 5 comes out and nothing remains in the root, right? So that itself is the answer for C. And let me move down to F of 1.8.2. The funny thing about this problem is I have fourth root outside outside, and I have fractional exponent inside the root, right? But if you think about it, the fourth root of something can also be written as fractional exponent, just like this, isn't it? So if I put parentheses and write 2 to the 4 over 3 power, which is inside right here, I can rewrite the fourth root as 1/4. Isn't that true? Because 1/4, you know, top powers and bottom roots. So having 4 in the denominator of the fractional exponent means it's fourth root. So this is exactly the same thing as this whole thing, right? Now, what can we do with these two exponents? Do we add them or do we multiply them? We multiply them. So it's going to be 2 to the 4th third times 1/4. And luckily enough, these 4 reduces, leaving only 2 to the 1/3 power. And since we started from root form, let me rewrite this thing as cube root of 2, and that's the nicest looking answer. Okay, be patient, we're almost there. I'll just probably go over 2 more problems and we'll end it, okay? So the second last question that I'm going to go over is 1.8.4. Not all of them, but only Star Spangling D, right? So let me enlarge this and work on it. All right. So again, I'm going to rewrite this as 2 separate cube roots, top and bottom. Cube root of 256 all over cube root of 27, right? Plus cube root of 32 minus cube root of root 12 over cube root of separately 81. All right. Now, what's the biggest perfect cube that goes into 256? Yeah, it is 64, which is cube of 4, isn't it? So it'll be cube root of 64, which is 4 cubed, and 64 times what? 4 is 256. Okay? Over, what is this cube root of? Cube of? That's cube of 3, isn't it? So I can rewrite that as cube root of 3 cubed. That's the same thing as 27. So I took care of the first term. And then, how about this? What's the biggest cubed number that goes into 32? It is 8, actually. So it's cube root of 8, which is 2 cubed, by the way. 8 times what is 32? 8 times 4 is 32. So I just rewrote this as this. And then, do I have any perfect cube that goes into 12, by the way? You know what? I think it's going to be easier if I reduce it, because it's the same cube roots, right? So I can reduce these two numbers, because 3 goes in here 4 times. 3 goes in here how many times? 27 times, right? So that's the same thing as cube root of 4 over cube root of 27. Well, cube root of 4, you can't really do anything about it. So it's still cube root of 4, but cube root of 27 can be rewritten as 3 cubed, right? So do you kind of see where it's going? Let me keep going a little bit. Now, who has the key? 4 has the key for cube root. So 4 comes out, but this 4 stays inside, unfortunately. Over 3 has the key for the cube root, so 3 comes out, plus 2 has cube key for cube root, so 2 comes out, and then 4 stays inside the cube root of, okay? And then this is cube root of 4 over cube root and cube. They cancel each other, so 3 has a key, so it comes out as 3. Now, is this simple enough? No, I have 3 different terms, but the thing is, I have common denominator here and there, but I don't have common denominator here, right? Then, you know what? I can multiply the invisible 1 denominator by 3 to make it 3. But I can't just multiply some number in the denominator. I have to be fair and multiply exactly same number on the top too. Okay? So what I have is common denominator 3 finally, and then I have 4 cube root 4s plus 3 times 2, 6 cube root of 4 minus 1 cube root of 4. And remember, they are all like radicals and they can be combined. You can think of cube root of 4 as $1, okay? So you have $4 and you gained 6 more dollars. That's $10 so far, but carelessly enough you lost $1. So I have $9. Okay, so it'll be $9, which is cube root of 4 over 3, and finally I can reduce these numbers, so it'll be 3 cube root of 4, and that's the final answer. I know this is not easy, this is quite complicated, but yeah, it's kind of worth it, right? If you do it, if you try this and solve it on your own, that's really great, right? So try it, okay? On your own. Use a stack of scratch paper, okay? Well, if you don't find any scratch paper at home, use some fresh paper. That's a good waste, okay? So you have to try it on your own on blank papers without looking at the solution manual, okay? On your own. That's the best way to study, isn't it? Now, one last problem that I'm gonna go over is the Star Spangling 1.8.7, which is the last problem of the review packet, right? So what they want you to do is they want you to simplify this whole thing so that it's as simple as something root another, something root the other, right? How can this whole thing be as simple as this? We'll see. And the good thing about this is it's all square root. It's not that bad, right? So let's get started, okay? Now, negative root 20. Can I break down 20? Does 20 have any perfect square? The bigger the better. What's the biggest perfect square that goes into 20? 4, right? 4 is 2 square. So 4 times what is 20? 5. So I rewrote root 20 as square root of 2 squared times 5, right? And I didn't forget to write the negative sign, because you shouldn't. Plus, don't forget about the 2 that's already outside. And what is the biggest perfect square that goes into 245? Remember we did this problem in class, right? It is actually, it's kind of hard to see, but it is actually 49, okay? So 49 goes in there 5 times, right? So 49 is square root of what? 7. So 49 times what is 245? 5 times, right? All over root 270. Huh. What's the biggest perfect square that goes into 270? It's not that big. It's 9. 9 is 3 square, right? So 9 goes in there 30 times. Okay. Minus, what's the biggest perfect square that goes into 120? It seems like it's going to be a big perfect square, but it's only 4 again. Okay. Which is 2 square, which is 4 times 4 times what is 120? 30 again, right? So guess who comes out of the square root prison? 2 has the key. So, oh, by the way, don't forget the negative. Ooh, we almost forgot. Negative 2 comes out. Root 5 could not come out. Plus, here, be really careful. 2 was already outside the square root. You should never forget that. So copy that down and multiply by 7 that has the key. So it escapes as 7, right? Because it has the key for the square root present. And then what happens is 5 remains in the square root because it does not have a key, right? All over 3 comes out again, leaving only 30 in the root, minus 2 comes out because it has key, and then 30. Oh, what do you see? What do you see here? Like radicals, these are dollars and these are pounds, okay? So, you lost $2, but what's 2 times 7? You gained $14. Overall, you gained $12. All over, well, you had 3 pounds, but you lost 2 pounds. It sounds like you're losing weight, right? So if you lost that much pound, 3 pound minus 2 pound, that's 1 pound, which is root 30. But teacher, that's not in a root b form. I know. But remember, within the same square root, I could reduce the numbers. Alright? So 5 goes in there 1 time, 5 goes in there 6 times. This is simpler. 12, well, root 1 is just 1, so on the bottom it's going to be root 6. But teacher, that's still not 8 times root b. Right. Remember, rationalize the denominator. You can get rid of the root in the denominator. How? What's opposite of root? What's opposite of square root? Square, right? So you want to multiply another root 6. But you gotta be fair. As soon as you multiply something on the denominator, you have to multiply the same number on the numerator. Okay? That's really important, right? So this is the same thing as square of square root 6. So they cancel each other, only leaving 6. And then you have 12 root 6. Oh, you see something, right? 6 and 12 can be reduced, and that leaves 2 here. Finally, you have only 2 root 6. So what's the final answer? They told you to find a and b. So what is a? This is a. What is b? Inside the root, that's b. So we can say a is 2 and b is 6. And that's the final answer for the last problem. Alright, good job. So if you understood all of this, that's really good. Please practice it on your own, and it will be really useful when you write a test correction. Okay? Alright, see you in the class. Bye-bye.